Good morning, everyone. Is my screen and voice clear?
Yes, sir.
Good morning, all. Monday session, I have given you a brief introduction about the subject, the do's and don'ts part, as well as I have touched upon other subjects. Okay. So in today's class, I will give some history about the origin of our subject. Why is it interesting? Why is it important? What are you exactly going to study in this subject? Okay, the next class onwards, we will be starting the actual syllabus proceedings. Only if you know the history behind our syllabus and the importance and the hard work done by the scientists at that time, only then you can indulge yourselves in the subject. Otherwise, for you, it can be appear as a simple unknown thing. That's it. Okay. Please listen. This history is very interesting behind our subject. So our subject is formal languages and automata theory, or simply formal languages, automata theory. How many of you know Alan Turing? Anyone from your section? Varun, kindly don't raise hands now, because all the time I will be sharing the screen, so I don't able to view the participant's name also. So if you want to answer any kind of question in the session, kindly unmute and talk. Okay. This instruction to all the candidates to the 3P1 section. Whenever I have asked a question or whenever there is a debate going on in the session, kindly do not post your answers in the chat box. Neither do raise your hands. There is an option for you to unmute and speak. So if you know something, if you want to add something relevant to the discussion that's going on, kindly unmute and like utter the answer. There's nothing wrong. Okay. Yeah, Varun, would you like to say something about Alan Turing?
Yes, sir. He was a famous mathematician and computer scientist, and he was responsible for breaking the Nazi Enigma code during World War II, sir.
So guys, Varun is of opinion that he is a great mathematician as well as scientist, and he broke the cryptic code during the World War II time, right? Yeah. So we fondly call Charles Babbage as the father of first computer, right? You might have been studying this concept since your 6th or 5th standard or so. Okay. But what Charles Babbage has developed is merely a calculator, a calci, not a computer. So at that time, the machine is of the size roughly equivalent to one classroom now in our ICT. At one corner, if you give the input as 2 plus 3, after 7 or 10 days, at the other end, you can see the result. So that's how the computing speed is at that time. So Charles Babbage merely developed an electronic device that can able to do some computations. Okay, basic calculations, not computations per se, but there are some other scientists who kept on working on the skeletal model given by the Charles Babbage, and so that's what has become modern day computer. So Alan Turing is one such forefather for all the computation. He developed automata theory. Okay. So actually, he's father of cryptography. As Varun has said, he's a British scientist. He used to decipher all the secret codes of Germany during the World War II. You are very aware that World War II happened in the time period of 39 to 45. It's essentially between Germany and other allied nations. So this Alan Turing worked for the British government. He used to decipher the secret codes of the German Navy and all. So in a sense that he played a key role in uh, winning the war against the Germany, which is a very uh, strategic and shrewd side at that moment. Okay, so he is the genius. So the modern cryptography we are studying, that's actually the subject you're going to study in the up next year, the 7th semester, 4th year. So this is basically science of hiding the actual data and transmitting the other data, or simply a secure way of communication. So today the network, the internet, everything is based on this cryptography. So he is the father of cryptography. Indirectly, he is also the father of artificial intelligence. So indirectly, he is the father of compilers and all the natural language processing, NLP. So if there is something to NLP, there is ML, there is artificial neural networks. So this all comes under one domain. Okay. So what the today's modern concepts we are exploring so far, in 30s, he is the one who has developed. So for all the modern day subjects, the base is automata theory. So we'll discuss something about automata. What is automata? It is a Greek word. Okay. This word derives its root from the Greek origin automaton. Okay, which stands for doing things on its own. Simply, it is machine. Okay. This is now become a common word that we use today, that is automatic. There is automatic air conditioner, there are automatic vehicles, everything is automatic. The advanced degree of automatic is autonomous. You might be studying, there are autonomous vehicles. Since ages, they have been designed by all the automotive companies. Tesla is also one among such. I think a couple of years ago, there is a autonomous system failure by Volvo. Guys has developed a car which brakes automatically, seeing an obstacle. The chairman itself, he stood across the path of the car, the system failed and has hit the chairman itself. There is a famous video of the same on the YouTube also, you can view it. So there's much research has been going on how to make the things automatically. Okay, so this is the Greek word automata or automata plural, which stands for automatic. So in a sense that it is a machine which makes the things on its own. So basically, but we have to give the instruction. Okay, so he is the one, Alan Turing is the one who developed this automata theory, the basic of machines. So if anyone asks you about a block diagram of a computer, how a computer works, you might be drawing the CPU monitor and all. But basically, this is what happens. There is an input, there is some processing, you get some output, right? So this basic model of input output with some process of computation is what generally essentially called as an automata theory. Okay, so he is the one developed the theory. He is the one who developed all the modern day computational machines. Okay, so he's such a great guy. But he's actually, many of the great people in the world, they suffered some painful deaths. Not many had a happy endings. So this Alan Turing also humiliated by some discrimination at that time. He was also kept in prison. So what he did is, some visitor gifted him an apple. He injected cyanide, the most powerful poison known to man, into that apple. He took a bit and died. Now, can you see something in this? Varun.
The Apple logo.
Yeah. Who is the founder of Apple? Who is the mastermind behind Apple Inc.?
Steve Jobs.
Yeah. So this guy, Steve Jobs, is an ardent disciple of Alan Turing. Okay, he used to worship this guy because of his mathematical genius and his thinking ability. He's an ardent disciple of this guy. So this Steve Jobs, he wanted to make the world know about this guy, because at the time the multimedia and the World Wide Web is not so prevalent. So many of that, even the computational professionals at the time, like in 70s and early 80s, they don't know much about Alan Turing. So this guy, he wanted to make sure that the world doesn't forget him. So that's why he kept the logo for his company as a tribute to his master, or tribute to his godly figure, Alan Turing. So there are many stories circulating that Steve Jobs sat in an apple orchard and apple fell, like the same Einstein theory and all. So my question is, if Steve Jobs is wandering something in apple orchard, why not get the same full apple logo? Why to have the cut? So that's the question. Because of this Alan Turing history. Just a second, guys. Yeah. Sorry for the information, guys. Yeah. So this is the story behind the Apple logo. Don't read the bullshit stories in the internet. Okay. So this is the actual reasonality behind the Steve Jobs choosing the half-cut apple for his company logo. Okay. So such is the great guy with Alan Turing. So, but unfortunately, due to his suicide, many of the automata theory, the work he's like developing the project or the science which we are studying today, has abruptly cut. Okay, the work is not complete. There should be someone who need to carry forward the legacy, right? Otherwise, the effort by this man would have been wasted. So, there is one such guy, Noam Chomsky. I think you won't be hearing of him too much, because this guy's name is generally first encountered in the formal language, this subject. I think you haven't heard this name before. If you have already heard, that means you are working very actively in the academics. Okay. So Noam Chomsky, he is a friend of Alan Turing. They used to work on some projects together. So he's a very, he know what exactly this Alan Turing's capabilities. So what this guy did is, actually this guy is working on some other front called as formal languages. As Alan Turing is working on automata theory, this guy, this Noam Chomsky, is working on formal languages. Okay, the natural language processing. Not the general language we do. There is certain rules for a language to be qualified as formal language, not the programming languages also. There is some set of rules that we are going to study in the upcoming classes. So what this guy did is, he is working on formal languages. He's a friend of Alan Turing. This guy died suddenly. So the automata theory has like kept it a halt. But this guy, Noam Chomsky, he could see some applications of automata theory in languages. He could able to link these. Okay. What he is of opinion that they both are not different entities. There is some connect between these two. Automata theory, the models developed by Alan Turing, has very good application for his study. So what this guy did is, he integrated both of this. So that's what became today's modern day subject flat. Formal language and automata theory. They are not different. They are one and the same. But essentially, in the 30s or early 40s, they used to be two different streams, but now they are integrated. The beauty with the computer science is we can able to blend any two domains. Okay, machine learning with bioinformatics, artificial intelligence with some other neural networks, anything. We can able to blend any of the given domains. That is the feasibility we had with the computer science. That's not the case with the civil and mechanical engineering guys or some other electrical core engineering branches. If the civil engineering, if he is dealing with concrete or sand, that all the basic construction pillars and all, he cannot able to do with the rest of the stuff. He can only concentrate on the structure. So the other guy, he could only concentrate on the flooring plan and how exactly he can fit into the spaces and all like this. So, but that's not the case with us. We have very feasibility of blending any two domains. So the same application you can also explore for your the mini project, or let's say your future projects, or any of such kind. Okay, there's nothing. I mean, in CSC that can't be blended together. If you have the interest, if you know a bit of programming, if you know the subject, you can able to blend any two domains. Okay. So this is the interesting history behind our subject. So this is not a application that has been developed in the recent past. It is age-old one. It is since from the beginning of the first computers, and it is directly handed over by the great scientist Alan Turing. Okay. So this is the history behind our subject. Now, a bit of a syllabus description. What exactly are we going to study in this subject? Now, there is two parts, right? The language part and automata part. So this guy Alan Turing has developed the automata theory. We are going to study all the concepts of the automata theory. So we have finite automata, a simple switch kind of machine. I'll give an example. You have an electric switch, right? Off and on, two actions. So let us assume off is one state of that switch, on is another state of that switch. In order to make it on, what is its requirement? An electric pulse is required, right? Electricity. So this is the input. So initially the switch is in off state. If I give some input E, electricity, it goes to on state. In the same way, if I disconnect that electricity, it goes to off state. So this is a simple automata machine of a switch. That's it. Everything we can able to do in the automata model. So for example, let's say there is a person, he is at Vijayawada, he want to come to Ushaipur. So this is one state, this is another state. So in order for a person to come from this place to this place, what is the total distance? Roughly it is 400 kilometers. Right? So if I give a constant input of 400 kilometers, a person from this place can reach up to this place. But if I have given the input as only 200 kilometers, not 400, he would reach some other state, which is Rajahmundry. All the combined Telugu states people can know this example. Those who are coming from not just view it as an example. Okay, there are two places situated distant at 400 kilometers. Okay, there is another intermediate place that's situated exactly in the midway between these two places. Okay, so if I give 200 kilometers as input, the person will reach some other state. Still, if you want to reach the final destination, there is one more 200 that has to be given from here. So this is the final state. So in automata, all the normal states are depicted with one circle, and the final state, in order to make it different from other state, it is given with two circles. Okay. So this all will cover in detail. Don't worry. Okay, this is just an example for you to understand. So the first topic we are going to study in automata is finite automata. Okay. Under finite automata, we are going to study some 5 kinds of finite automata. Okay, finite automata are 5 types. We are going to study the finite automata. We have non-deterministic finite automata. So we have formally DFA and NFA. All the first 2 units you will be dealing with these 2 concepts, which are very interesting. But all need is you need to work on. As I have said in the earlier class, this is not a theory subject wherein you can just simply view the lecture. There should be a running notes for you for this subject. whenever I'm explaining a concept or problem, you need to work parallelly. Else, at the time of examination, it will be a very hard nut to crack. So, okay. So we'll be studying the automata 2 machines, the basic automata. We have one more thing called as pushdown automata, PDE. Okay, pushdown automata. So why it is called as push down? Because this automata, this kind of automata is having a stack. Generally, in stack we have push and pop operations, right? So anything, it is pushed down into the stack. So that's why the name push down automata. The difference between this machine and this machine is memory, which is the stack itself. So the basic finite automata and MDFA, they don't have a memory, but whereas this PDA has a memory. For example, if I has given a task of scanning 2 A's and 2 B's, okay, scan, when the task is to scan 2 A's and 2 B's, whether it is accepted by a machine or not. There is a machine which accepts 2 A's and 2 B's. My task is to give this problem to this. These two guys will do it, no issue. This guy is also do the thing. But the problem is, if I ask this DFA or NFA guys, what have you done? They don't answer because they don't have any memory. They simply take the instruction and process. What are they processing? They don't know. But here in PDA, if I ask the same question, my dear PDA, what have you done? There is a memory. So already there are 2 A's and 2 B's in its stack. So it can simply say, I have studied 2 A's and 2 B's. Okay. So that is the memory, I mean, the difference between these two machines. So this is PDA. And we have the most important machine called as Turing machine. The one, the directly, the main model developed by Alan Turing. It's simply called as TM. Okay. This is much more powerful than PDA. It also has memory, but in a sense that it has infinite memory. So there is not feasible infinite memory, but for studying sake, we just call it as PDA to be limited memory. Turing machine has infinite memory, so it is very powerful machine. So it has two kinds of memory. It has a buffer as well as stack. So this Turing machine will take input from buffer and process into the stack. Very interesting concept, these two. So these three machines essentially are developed by the Alan Turing. Without memory, with more advanced memory. So these are the three main topics that we are going to study in the automata part. Okay. Guys, are you following?
Yes, sir.
Okay. So in the languages part, so this is by Turing, Sir Turing. This is by Chomsky, and Chomsky, MC. So this guy will study some concepts of formal and regular languages. Okay. So we have formal and regular language basics. This is first thing, the basics of languages, the rules and all, the noun lecture. Second, we are going to study a nice tool called as regular expressions. Okay. So this is a powerful language construct that can be able to represent any kind of thing in a formula kind of way. For example, I will give a small example. 356. For 356, the regular expression is as follows: digit star. So 356 are digits. Star stands for multiple occurrences. So the machine don't know 356. It know only the pattern. By able to see digit star 356, whether these two are same. I mean, this is input. The machine need to have something to compare, right? So it has this part, the regular expression part. If it sees whether it has fallen under this category or not. So 356, the three are digits, multiple occurrence. Fine. So this is a digit valid. If I say 3AB, I'm checking with the digit star, right? So 3 digit, fine. AB, they're alpha characters. So not a digit. Like that, the system will return the value. You might have seen in a simple C programs and all, whether the given input is a prime number, whether the given input is a parent or not. So this is the basic behind the system. This is how the computer would actually compare. So again, this is also a basic example. We are going to study much more detail. Okay. So third part, we are going to study grammars, not the English grammar, no, all that V plus forms and all. The basic formal language grammar. What is the form of a grammar? What is the rules? What are the types of grammar? What are the problems with grammar? That's all we are going to study. So basically, we have 3 topics of automata and 3 topics of languages. Second, yes. Yeah. So now we'll have a mapping between the actual syllabus to our Gitam syllabus. Okay. So in unit 1, we are going to study the language basics and the first machine of automata. This is unit 1 of our Gitam syllabus. Some basics of languages, the first machine. Okay. Exactly, the entire regular expressions is covered in unit 2. And we'll have some relation between regular expression and automata. This is a very important question. So how are these two related? We'll able to establish a relation. So this exactly is unit 2. The grammar entirely is unit 3. Okay. What are the types of grammars, the problem, everything we'll discuss it. Okay. Still we have some like relation between these two as well. The interlink chain continues. Finite automata to regular expression to grammar. These are like a basic building block. Okay. So this is unit 3. This pushdown automata part is entirely unit 4. The last Turing machine is unit 5. Okay. So the syllabus is very evenly, uniformly, and beautifully distributed. The syllabus is very less, but it's very tricky and it involves a lot of your attention and understanding. If you listen the classes, if you know the subject, and if you practice well, this will be very, very easy. Else, on the contrary side, if you don't listen the classes, if you don't know the basics, if you don't work it out, it will be very, very tough to understand and even to clear the examination as well. Okay. So, on the positive side, if you review, these are the 6 topics we are going to study it in the entire semester up to October ending. Okay. November 9th, I think there's the start of your semester examinations. So hardly we'll be chopping up the, wrapping up the syllabus by October 1. So take this 10 days aside, in the month of July, we have 3 full months, August, September, and October. Okay. So we can go in a relaxed fashion. There's nothing for us to hurry. Okay. It's not like some other vast theory subject which we need to cover in time. 3 weeks, 3 classes per week is more than enough for me. Okay. So we'll go on a relaxed mode from the next week onwards. But as I said earlier, yours attentivity and yours understanding is the foremost thing in the subject. So still, if you have not obtained a running note for the subject, kindly do take one. From the next actual Monday session onwards, actually the next session is also somewhat basic insight stuff. I don't start the actual syllabus in the first week itself. I want you to familiarize with the concepts itself. So the tomorrow's class is also somewhat a basic introductory class. In the next week onwards, from the Monday class onwards, I will be jumping into the actual syllabus. So by the time, please be prepared with the actual running notes. Okay. Yeah, so we discussed about the history, interesting history of the subject. I discussed about the syllabus. I've given you the mapping view also, our given syllabus, and I have given some instructions as well, do's and don'ts. Any query from your end? No? Till now, with the 2 classes so far.
No, sir.
Okay. There's still 10 minutes more now. I will touch upon some basics of language. Now, anyone tell me why we call, why the name alphabets? How did the word come from? Anyone? What are alphabets now?
Lexicon, A, B, C, D, H.
Basic characters of the English language. A to Z, which is 26 a number. We call them alphabets. Now my question is, why exactly the word? What is the first language, the first earlier language decoded by the human beings?
Latin, sir, Latin.
Latin. Okay. Isn't it Greek?
Yes, Greek and Latin.
So something if you don't understand, we simply accuse Greek and Latin. Okay. So, Greek and Latin, they both share the words, the root word from the same language. So, Greek is the actual language which is deciphered by the humans earlier. Can you tell me some of the Greek alphabets?
Alpha, beta.
What is this? What is this?
Beta.
Now, can you see some relation?
Yes, sir.
Has anyone thought of this prior to this session?
Yes, sir.
Then it's fine. So, is essentially alpha betas because the alpha betas of English are ABC. See, even they are derived similarly. A for alpha, B beta, similar kind of thing. But as we humans are very lazy, in the course of time, this A has lost alphabets. That's it. Okay. So, alphabets are in English, essentially, they are the basic characters, right? But in formal languages, there is a little difference. Okay. Here, the basic building block of a language, we call it as a symbol. Okay, that is the difference. Collection of symbol is alphabets. The collection of alphabets is strings. And the strings make up language. So this is a formal language. If I talk about normal language, which is English, we have alphabets, we have words, words make sentences, and sentences plus grammar make up the language, right? So this is the hierarchy in the general English, the communicative English that we use for the daily communication. But here in the formal language, there is a little difference. Here the basic characters are called as symbols. Okay. For example, I'm saying I have a language M. I have a language. The name of my language is M. M has 3 characters or 3 symbols. Let's say these are my 3 symbols. Okay. Yeah, this is my language M. I have only 3 symbols. Okay. So basically, the alphabet is not essentially the collection of symbols. No, it also depicts the range. Okay. The range of the symbols as well as the combination. That's what the alphabet is. So here in the formal language, this alphabet is somewhat tricky concept than the alphabet we know so far. Okay. So what we need to know is in formal language, the least common, the least addressable element is symbol, and alphabet is collection as well as a range of the symbols. Okay. And this alphabets make up a string. So this string can be combination of the symbols. So it can be these 2, it can be these two, or these two, or all the three taken together. The three are separate as symbols in strings, they come up as one entity. So language is made of strings. Okay. So this is the basic differentiation between the normal language and the formal language we study. Okay. Now, can anyone tell me about what is a prefix? This is the word formal. What is the prefix for this word?
IN.
Hmm? What is the prefix for this word? What is a prefix?
Sir, when you place a like a word before another word, for example, informal, so in would be the prefix.
Okay. Who is this?
Sir, rule number 18.
What's your name?
Tanmaya, sir.
Tanmaya.
Mm.
Okay. See, Tanmaya, what you have said prefix is normal language. Okay, that's fine. Something attached in between, I mean, for the word, right? But in formal language, prefix is anything that make up the word starting from the left corner. So F is a prefix for this word. FO, FOR, FORM, FORMA, and the complete as well. FORMAL. This is the longest prefix. Okay. We don't want the English prefixes here that gets attached before the word. So here in formal language, all of you kindly listen to this now. Prefix is for any given string. If my string is A, B, C, D, starting from the leftmost character, all the given lengths are prefixes. So A, B, ABC, ABCD is also prefix, which is the longest prefix. Okay. So now under the similar lines, Tanmaya, could you tell me what will be the suffix?
So starting from the rightmost character, all the given characters will be.
So L, AL, MAL, RMAL, ORMAL. What will be the longest suffix? Formal, right? So as per the language theory, the formal language theory, the word, any word W is equal to the longest prefix or suffix. Okay. Now, we call something about modulus. In mathematics, you might have studied the modules operator, right? What will the modulus do? One basic application is given any negative number, it will turn into positive, right?
Yes, sir.
Yeah, but here in formal language, modulus determines, this modulus function determines the length of the word. Okay, these are all we are going to study in the first and second units. That's why you need to know all the basics. Okay, so modulus determines the length of the word. UBCD mod. What will be the value?
4.
4. Perfect. Okay. So whenever I say modulus for a word, it determines the length. Okay. Now there is an important entity called as empty string. So this is very, very important in our languages. Now, what is an empty string? An empty string is determined by epsilon, the Greek symbol epsilon. Why we call it as empty string is whenever it is kept in a modulus, the value is 0. Okay, there is no length, there is nothing. It is empty string. Okay, but if it is empty, it has nothing to do Why are we discussing about this so much? Because there is a guy, a scientist who is called as Kline. Okay, he is very much obsessed with this empty string. Okay, he has given a like definition or his own theory. The theory is such that if there is a words collection, okay, if W is a word from the alphabet range A, B, C, D. So what are the all possible things? There is a AB, there is ABC, ABCD. And the same goes with B, right? BC, BCD, CD, like all such stuff. So what this guy Kline said is, given any alphabet, given any words in the collection of the strings, there is always an empty set. Let me change that. We don't know why this all mathematics are of different and contrasting opinions compared to the normal humans. But what this Kline said is, any alphabet, any closure, that means a collection of strings over any alphabet in the world, it by default contains epsilon. So whenever you're determining the number of counts for an alphabet, you should always add +1 because of the empty string. That's what Kline has said. So such a closure over any alphabet containing epsilon, it is called as Kline closure. Okay. So Kline closure is something over an alphabet that contains empty string. So there are other group of scientists as well who don't like this Kline's opinion. They simply made another closure. What is the thing called as? It is called as positive closure. So removing the epsilon, all other characters, they are in positive closure. Okay. So these two closures you should be knowing. Okay, this Kline closure is determined with the symbol star. This positive closure is determined with the symbol plus. The difference is in Kline closure, there is an epsilon, null string always. In positive closure, there is no epsilon. Okay. Yeah. So this is pretty much the basics of the languages now. Okay, in the next session, we will be dealing about the basics of automata theory. Okay.